Hello everybody, welcome to my channel of AG Math, the way of life. AG Math, the way of life. We have discussed about binary operations and complex numbers in our previous video lectures. Today, I have picked up the topic of quadratic equations. In quadratic equations, what we are going to study today is what is the definition of quadratic and what is called the roots and methods of solving the quadratic equation, nature of the roots, how the roots behave, and the relationship between the roots and coefficients of the quadratic equation. Finally, the equations which are reducible to quadratic form. Now, to tell you about the history of this quadratic, the Arabic mathematician named Muhammad ibn Musa al-Khwarizmi, maybe I cannot pronounce his name properly because it's an Arabic name. About 825 AD back, he wrote a book, the first systematic book of algebra, where he discussed about how to solve the equations. And the method what he adopted was called the completing the squares. And by that method, we could only get the positive values. Now to start with, what is the definition of quadratic equation? I tell you, what is an equation you know? Equation is equating some unknown with some known thing. Suppose we have got a physical balance like this here, and you have some unknown elements put on the left hand side of this pan. We have something which are unknown here. Suppose these are the items which are not known. And if I put some elements which are known to me, some value say 5 or 7, then whatever I have put here will be equal to 5 if the beam remains parallel, horizontal and parallel to the ground. That means we say that left hand side is equal to right hand side, the unknown is equal to the known which I have put here. Suppose I increase this side by some amount, say another y, then I have to add something more here, say about 7 to equate that. Then when we again write the equilibrium format, then it becomes y plus x is equal to 5 plus 7. And this is what is known as a equation. And it is in the linear form. And linear means the power of the unknown variables, this x and y are the variables, should be 1. If the powers are more than 1, the name changes. The equation name changes accordingly. When highest power is 1, highest power of variable is 1, we call it linear. Like x plus y is equal to 10 or something, or x is only equal to 5. If the highest power of equation is of 2, then it becomes quadratic, as we are going to discuss today. If the highest power of the unknown is 3, then we call it as a cubic. If it becomes 4, then we can call it as polynomial or even biquadratic. Biquadratic or a polynomial. And likewise above, maybe 5, 6, 7 up to n, it can go. So this is what is the definition of a equation and different powers and accordingly their names. Now to give you an example of quadratic equation, normally it is written as, a quadratic is normally written as ax square plus bx plus c. This is an expression. An expression and equation are two different things. Expression doesn't have a right hand side. If we call this as the left hand side, this is only the expression. And if I equate it to something, say k, a numerical number or a constant number, then it becomes an equation. So this is the quadratic form of equation. We have to uh, find the solution by factorization. This we have already learned in our earlier classes. Factorization. Let the factors be equal to, I write is equal to px plus q and rx plus s. Let these be the two factors, px plus q and rx plus s, where p, q, rs are the constant, where p, q, r and s are constant. Correct. Then we'll have two values for x. Right. If I write this is the product of these two, then either px plus q should be 0, or if this is not equal to like this, it is equal to 0, then this part is written as this. Left hand side is this, LHS. I write the LHS like this, then px plus q is 0, or maybe rx plus s is equal to 0. If this is 0, then what is the value of x? I get value of x as minus q over p, and here I get value as minus s over r. So these are the two different values of x, and we say these are the solutions or the roots. Solution or the roots. This is what is the meaning of the word roots. I have explained you about the definition of quadratic and what is the roots of it. Now, methods of solving, we know about factorization. Secondly, we will start today, which is called the completion of the square. Let's start with the process which is called completion of the square. Let the equation be x square plus 10x is equal to 39. I have taken a definite type of numbers here, a, b, c. Instead of unknown values, I have kept it as 1, 10 and 39, minus 39. If this is a square, then our Arabic mathematician, whose name was Muhammad ibn Busha al-Khwarazmi, suggested that you start with the square of side x, which represents like this. We say that you start solving this by the side of x. If this is x and this is x, then the area is called x square. Right? This is the first step. Form a square of side equal to x. What was the second step? He suggested that we have x square plus 10x, no? So I have created the x square part here. Now I have to add 10x to this. So how will I add 10x? This side is x. So if I add a small area which is equal to 10x and divide it by 4, because I'll add the same area on the 4 sides. So 10x by 4 is called 5 by 2 of x. Right? When you simplify it is 5 by 2 of x. So if I am adding 5 by 2 of x to this square, I draw it here so that I can draw the last one down. Suppose this was my original square of x. I have further added some area here on the 4 sides. What is this? This is 5x, 5 by 2 of x. This was x square. This is also 5 by 2 of x. This is also 5 by 2 of x and 5 by 2 of x. Then what happened? I have taken the left hand side in this figure. X square plus 10x. This is only x square. Now this is called x square plus 10x because I have added 10x, which is like this. 10x divided by 4 each side of the original square I have added 5x by 2. So now we have a figure which is representing x square plus 10x. Now you see, what is this portion? This portion is nothing but 5 by 2, and this is also 5 by 2. This is 5 by 2, and this is also 5 by 2. Because the area of this rectangle, I say it is 5 by 2 of x. And if one side is x, then the other part which is extended must be 5 by 2, resulting into 5 by 2x. So that is the 5 by 2x. Now, third step, what is they said, you complete this square. This is not a full square. So now I will complete the whole square like this. Now this is the whole square which is having the center part as x square. This much is 5x by 2. The red part I will write. This is 5 by 2 into 5 by 2. This is also 5 by 2 into 5 by 2. This is also 5 by 2 into 5 by 2. And this is also 5 by 2 into 5 by 2. Right. And suppose this part is my x, this was x, this was x, and this was x. Correct. And this is as earlier 5 by 2 of x. This is also called 5 by 2 of x. This is the area. I'm talking of the area. This is called the area 5 by 2x. And x is only the side. It is 5x by 2. This is the area. Likewise. So I have completed the entire square. Now we can say the outside area, this whole thing, a big whole square, has become x square. This is equal to x square is in the center. Then I have added 10x by 4, that is 5 by 2x, and what I have also added at the 4 end is 25 by 4, 4 times, plus 4 into 25 by 4. I hope you all understand this. This is 4 into 25 by 4. So this much I knew as per the problem. This was 5 by 2x into 4. So it is 10x. Practically it was 10x. So from here to here, this much is as per the question equal to 39. Now 39 plus this 25 is becoming equal to how much? 64. So this figure is becoming 64. That means this whole area is outside area of this big square is 64 units. And in a square, if the area is 64 units, then means that individual values are 8 and 8. This should be 8 and this should also be 8. So practically we got the value of this thing. What is this? We can equate now that x plus 5 is equal to 8. X plus how much? How much is 8? This is 5 by 2. No, it was x plus 5, right? X is this value, no? From here to here is the x value. And what is this? This is 5 by 2 and this is 5 by 2. So x plus 2 times of 5 by 2, which are the small length. This is equal to 5 by 2. This is also equal to 5 by 2. And in between it is x. So we can write the whole side is x plus 5, 2 times 5 by 2, and that equals to 8. Now 2 cancels, therefore we get x value as 8 minus 5 or equal to 3. So x value I am getting only 3. If you put it here, you see it satisfies or not. 3 square is 9 plus 10 into 3 is equal to 39. So it is satisfying the given problem. If it is satisfying, that means x is the root of this equation. X square plus 10x equal to 39. And we are getting only the positive value because earlier days, these mathematicians considered only the numerical numbers as positive. There were no negative numbers as such. The negative number only was introduced by the physicists when they look at the number line. This is 0, this is 1, 2, 3, 4. These were the positive numbers our arithmetician calculated. Then physicists started telling that we have also minus numbers which is actually not existing. We cannot say this is minus 2, this is minus 3, but we can definitely say this is 2 and this is 3 or this is 4. So physicists decided that whatever action is taken, there is an equal and opposite reaction as per the Newton's law. So if one unit is on the right side starting from a reference point 0, then one unit should also exist at the back of it, which is will be called as the negative part. Because both cannot be called 1. And then they say that treat this as a mirror and you have the object here, so you get the image exactly at the same distance behind the mirror. So every action has got the equal and opposite reaction, or the object distance is equal to the image distance. Accordingly, they decided that you can have minus infinity to plus infinity separated by a line at the point 0. And that is how the definition of 0 came. That 0 is separating a number line into two parts, which is negative part and the positive part. That's why we got earlier mathematicians or arithmetic algebra people decided that there is only positive values of measurement, there cannot be negative measurements. So we got x is equal to 3 by the completion of the square. Now the nature of root and relationship between them I'll discuss in the next clip after this. If you like my videos, I again request you to please click on the icon and subscribe as well so that you get the intimation of my next videos whenever I am posting it. Thank you very much for watching and for your valuable time. See you again.